everyone, welcome to SCI-EASE. In the last video, we discussed about the spherical mirrors, that is concave and convex mirrors. Like plane mirror, image is also formed by the spherical mirrors, that is concave mirror and the convex mirror. For that, the extended object we will take of finite size, and each point of that extended object will act as a point source, and rays, they will start from that object and they will strike the spherical mirror. Number of the rays, they will start and they will fall on the mirror. But in that case, the ray diagram, that is not clear. For our convenience, we will consider only the two rays, and where these two rays they intersect, the image that will be formed. So before doing the ray diagrams, in which the object is placed at various points, like at focus or parallel to the principal axis or at center of curvature. So many ray diagrams we will do, but for that, prior to that, you should know the rules for drawing, for tracing, you can say, these rays. So my topic is rules for tracing images formed by the spherical mirrors. So rule 1. First rule is a ray parallel to the principal axis. What is principal axis? This is the principal axis on which pole, principal focus and center of curvature is there. Okay. So a ray, this is the concave mirror, that is the inner side of the spoon. The ray parallel to the principal axis will fall on the mirror and it will pass through the principal focus. This is the principal focus. Okay, parallel, you will show the direction of the ray like this. It will fall here and this will pass in this direction. Okay, and another ray that will pass through the center of curvature, and you will see that the law of reflection, that is angle I is equal to angle R, that will be followed everywhere. This is angle I because this is the incident ray and this is the reflected ray. Okay, so first rule is when the ray it is parallel to the principal axis and after reflection it will always pass through the principal focus. But in the case of the convex mirror, the ray parallel to the principal axis will fall on this point, okay, and this will be reflected back in this direction. But when we will produce it, it will pass through the focus, principal focus F, okay, and here angle I, that is this one, angle I, and this is angle R. Okay, so a ray parallel to the principal axis after reflection will pass through the principal focus in case of concave mirror, or appear to diverge. It will appear to diverge from the principal focus in case of the convex mirror. Okay, so this is the first rule. Now the second rule is a ray passing through the principal focus of a concave mirror or a ray which is directed towards the principal focus of a convex mirror after reflection will emerge parallel to the principal axis. This is, second rule is just the reverse of the first rule. In the first rule, the ray parallel to the principal axis after reflection will pass through focus, and here the ray which passes through the principal focus, direction that I have changed, okay, that passes through the principal focus becomes parallel to the principal axis. In the same way, and here, what will be the angle I? That will be changed. So angle I is this, there angle I was that, and angle R is this, okay. In the same way, the ray which appears to pass through the focus, okay, it will become parallel. After reflection, it will become parallel to the principal axis. So here this is angle I and this is angle R. So second rule, that is just the reverse of the first rule, okay. A ray passing through the center of curvature of a concave mirror or directed in the direction of center of curvature of the convex mirror after reflection is reflected back along the same path. Okay, this ray is passing through the center of curvature and it strikes the concave mirror. It will come back in the same direction. By arrow you can say that it's going in this direction and it is coming back after reflection in the same direction on the same path. In the same way, not direction, on the same path you can say. And here also it's going here, it will strike here, and if we will produce it, it appears to come from C and it will also go in the same path. Why? Because it strikes the reflecting surface as a normal, okay. So it will come back on the same path in both the spherical mirrors, that is concave mirror and convex mirror. So this is rule 3. Now the fourth rule is a ray incident obliquely to the principal axis towards a point P. What is this point P? It is pole of the mirror, of the concave mirror or convex mirror is reflected obliquely. So here this is the incident ray which is falling obliquely at point P with the principal axis and it will form angle I, and this will be reflected back obliquely forming angle R with the reflected ray and the principal axis. In the same way, in case of convex mirror, same is the case. Here also angle I is equal to angle R. So remember this thing, that in all cases, the angle of incidence, that is always equal to angle R, that is law of reflection, that is followed. Okay, so in the next video, we will draw the ray diagrams for the concave mirror. Okay, and you will see, for that you should know all these 4 rules. First rule is that when a ray parallel to the principal axis, strikes the mirror, it will pass through the focus. Second, when a ray, it passes through the principal focus, it will become parallel to the principal axis. Third rule is, when the ray passes through center of curvature and strikes the mirror, it will come back on the same path. And the fourth rule is, when the ray incident obliquely to the principal axis, it will be reflected obliquely with the principal axis. So, you must know these rules for drawing the ray diagrams. They are very, very important from examination point of view, both ray diagrams of the concave mirror as well as the convex mirror. So, in the next video, we will practice all these ray diagrams. Till then, thank you very much.